Do you have any questions for me before we get started? Okay. So in lecture one, again, I'm going to go over the coordinate system, right? The four coordinate system we're talking about is Cartesian coordinate system, polar coordinate system, cylindrical, and spherical coordinate system. We derived the formula that connects rectangular coordinate system with other system, polar coordinate system with cylindrical coordinate system, and toward the end of the last time, we derived the formula to connect the coordinate cylindrical to connect the Cartesian coordinate system with spherical coordinate system. So these are the formula that we need to use for examples. So let's take a look at example 3. Right, so you have given this point, and this is in cylindrical coordinates. We want to convert this point to rectangular coordinate or the Cartesian coordinates. So by looking at this point, I have r equal to 3, theta equal to pi over 3, and z is equal to -4. All right, so let's identify that much. So this is r, this is theta, and this is z. And we're going to utilize this formula right here. All right. So x equal to r times cosine theta, y equal to r sine theta, and z equal to z to convert the point from cylindrical coordinate to rectangular coordinates. So we have x equal to r times cosine of theta, or you do 3 times cosine of pi over 3. Y is equal to r times sine of theta, or this is 3 times sine of pi over 3. And z is just equal to z, right? So in this case, z is equal to -4. All right, okay, questions for you. What is cosine of pi over 3 equal to? Yes. 1/2. So you have 3 times 1/2, or 3 over 2. And what about sine of pi over 3? Go ahead. Good. Yeah. So you have 3 times √3 over 2, or you can write 3 times √3 over 2. So the point in rectangular coordinate is, so the points in rectangular coordinates is 3 over 2, comma 3 times square root 3 over 2, comma -4. Again, so don't worry about missing a few minutes of class, right? I'm recording the video, so we'll upload the video later on Blackboard, and you can rewatch that when you have time. Okay, so any questions on problem A? Good. All right, let's move on to problem B. Now you are given the point in spherical coordinates, you can convert that to rectangular coordinates. Okay, so for spherical coordinates to rectangular coordinate, we're going to use this formula. So x equals this, y, z. One thing I want to point out, I mentioned this last time, in spherical, between mathematics and physics, there's a little bit difference. So the point should be rho, theta, and phi, while in physics, they use rho, phi, and theta. Right, so the name is a little bit different, but we're going to stick with math conventions. Okay, so here, this is rho, this is theta, and this is phi. And the formula we use is x equal to rho times psi of phi times cosine of theta. Y is equal to rho times psi of phi times psi of theta. And z is equal to rho times cosine of phi. Given that phi is equal to pi over 6 and theta is equal to pi over 4. So rho is a times psi of pi over 6 times cosine of pi over 4. For y, you have 8 times psi of pi over 6 times psi of pi over 4. And for the z component, you have 8 times cosine of pi over 6. All right. Beside Bobby, what is psi of pi over 6? Let's start with something easier. What is cosine of pi over 4? Root 2 over 2. And now what is psi of pi over 6? One half. Yes. So you have a times 1/2 times root 2 over 2. And this is 2 times root 2. So a divided by 4, you get 2. And for the y component, you get 8 times, what is psi of pi over 6? So root 3 over 2. Oh, sorry, 1/2 again. And psi of pi over 2 is root 2 over 2. So you get 2 times root 2. And cosine of pi over 6 is now root 3 over 2. So you have 4 times root 3. So the point in rectangular coordinates is 2 times root 2, 2 times root 2, 4 times root 3. Yes.
On work conversation, do you want to break out one in whatever point is and then the point, or just the point?
The point could be okay. So this type of question would be the online homework and setting up the online homework. For the written homework, you will see that you will know exactly what to write in the written homework. More specifically in example 4, 5, and 6, that you need to write down the details before you get to the yeah. Any questions on A and B on example 3? Good. For example 4, I make a typo here. Can you change the formula a little bit? So the question is, can you convert the equation in rectangular coordinates? For the circus. Why the equation in rectangular coordinates given that we have the equation in spherical coordinates? So this should be psi of theta times psi of phi. Now go back to your note, go back to the formula that connects between the spherical coordinate and rectangular coordinates. Can you give me an idea of what to do with this problem? Right, so this is in spherical coordinates, right? You want to convert this into rectangular coordinates, so I want to see x, y, and z in the formula. When I write down the solution, it's very simple. Don't overthink this. Now take a look at the right-hand side. Right, you have psi of theta and psi of phi. Does that looks similar to something in coordinate, rectangular coordinates? Y, right? So what is missing from what from the left, from the right-hand side? The row, right? So row is going to be always 0 pi. So we can multiply both sides for row. Right? So from here you can write rho times rho equal to rho times psi of theta times psi of phi. Right. So the right-hand side is y. The left-hand side is rho square. What is rho square equal to in terms of x, y, and z? Yeah. Just x squared plus y squared plus z squared. Very straightforward, yes. So x squared plus y squared plus z squared equal to y. So this formula represents whatever you have in spherical coordinates, right? You convert that into good, simple, right? Not too bad. Any questions? What about this one? Convert r equal to 2 times psi of theta from polar coordinates to rectangular coordinates. Give me the first step. How about that? First step. All right. So the right-hand side again is psi of theta. Go back to formula for polar coordinate with rectangular coordinates. You will see that psi of theta looks very similar to the y part, but the y component. So what is missing this is r. So you multiply both sides of this equation by r, very similar to the last example. So if you multiply both sides for r, you get r times r equal to 2r times psi of theta. And the right-hand side now is 2 times y, and the left-hand side is just x squared plus y squared. Okay. In the next example, you want to convert this equation in spherical coordinates to Cartesian coordinates. Okay. Again, to do this, I want to make x, y, and z appear in my equation. So to do that, what I'm going to do is I'm going to multiply again both sides for rho. So I have rho squared times rho equal to 3 times rho minus rho times cosine of phi. Can you tell me what is rho times cosine of phi equal to in terms of rectangular coordinates? Z, right? So this term should be Z right here. Okay. Now roll, we derive the formula right here. Let me scroll up a little bit. So you have this formula that rho squared equal to x squared plus y squared plus z squared, right? So to get rho by itself, take the square root of both sides. Yeah. Right. So rho technically rho is equal to square root of x squared plus y squared plus z squared. So here, so you have x squared plus y squared plus z squared sorry, should be square, times square root of x squared plus y squared plus z squared. So that's the left hand side. The right hand side is 3 times square root of x squared plus y squared plus z squared minus z. Right, so it's a curve when it has one curve out there so that we have some practice on converting from one coordinate system to another coordinate system. Any questions on example 5 and example 6? Good. So if I give you something like this in the homework or in the test, can you do it? Not too bad, yeah. Example 7, convert this from cylindrical coordinate system to Cartesian coordinate system. All right. Now we'll take a look at the left-hand side. You have sine of theta, you have cosine of theta. The missing information is r. So if you multiply both sides for r, you're going to get 4r times sine of theta minus 2r times cosine of theta equal to r squared divided by z. Right. So r times sine of theta is y, r times cosine of theta is x. So you get 4y minus 2x equal to x squared plus y squared all together divided by z.
That's what our life is called.
For what? Just for what? So r times sec theta, the whole thing is what? Okay. Now for the last example. So you want to convert this equation from Cartesian coordinate to cylindrical coordinate. So this one is a little bit easier because you have formula and you just pull up in formula. You don't have to do any manipulations on this equations. So Cartesian coordinate to cylindrical coordinate, you have x equal to r times cosine of theta, y equal to r times sine of theta, and z is equal to z. And you substitute all of this information to the equation, you get right, r times cosine of theta altogether cube plus 2 times r times cosine of theta altogether square minus 6z equal to 4 minus 2 times r times sine of theta square. You can manipulate this equation further to simplify the equation to get the final answer. So what I usually do for this test, if you have any time, any question like this, is that I give you multiple choice one, and then so that you can know what to manipulate and when to add manipulations to get the correct answer. Right, so technically this is done, right, because you starting from rectangular coordinates and go to cylindrical coordinates. Any questions? Good. All right. So that's it for me for this lecture. Again, this lecture will go back and review the 4 different coordinate system, including rectangular coordinate system, polar coordinate system, cylindrical and spherical coordinate system. The big part is to convert from one system to another system using the formula that we run in the lecture. Okay. So let me stop right here for this lecture. Let me move on to the next lecture. We're going to review the vectors, scalars, and dot product.